Okay, exponent laws. Radicals first. So let's do radicals. So let's take a look at the square root of 12. So what I'm going to do is, off to the right, barely, do a prime factorization, 4 times 3 and 2 times 2. Then I'm going to write root 12 as 2 times 2 times 3. So, in the English instructions off to the right, the square root of 2 times 2. Well, 2 times 2 is 4, and the square root of 4 is 2, so the square root of 2 times 2 is 2. Obviously. So, if that's equal to 2, then that's equal to 2. Not under the square root, equal sign. Well, that 3 is still underneath the square root. Circle your answer. Now what I failed to do is put the tiny little 2. So I'm just going to put that in big blue right here, a tiny little 2, square root. Remember to put that tiny little 2. It's very helpful. I just put it in the answer. Now, check your answer. So always, not sometimes, not when you want to, not just always. So type in the question, square root 12, and the square root of 12, the question is 3.46. Type in the answer, 2 square root 3, and the answer that we circled is 3.46, meaning that our answer is correct. It's a great way to allow you to study at home. Being able to check your answer on the calculator without having to ask the teacher, I don't have the answers, or whichever. Figure it out. Okay, so off to the right, there's a method called perfect squares. So let's do the same question, root 12. I forgot the tiny little 2. Notice that tiny little 2 is everywhere in the notes, and we should put it. So we want to multiply, we want to find, I'm going to read the English instructions from the notes. Find two numbers that multiply to the number underneath the square root such that you know the square root of one of them. So let's write down our perfect squares. So our perfect squares are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times whichever, etc. Now I want to choose one of these numbers that multiplies to get the number underneath the square root, and that's 4 times 3. So I can rewrite it as root 4 times root 3. That's allowed. And the square root of 4 is 2. And then root 3 we don't know. Circle our answer. We know it's correct because we typed it into our calculator and checked. So you can either do what's called the prime factorization method or the perfect squares method. I recommend prime factorization on more difficult questions because sometimes it's difficult to figure out what two identical numbers that you know the square root of one of them, and then you might have to do it again and it gets really confusing. So prime factorization is the method that we're going to go with. Okay, next question says it says the square root of 18. Notice I put the little 2 there, square root of 18. Well, we can do prime factorization on the 18. 18 is 9 times 2 and 3 times 3. And, I'm going to put the 3 a little bit more to the right where it belongs. And then we can rewrite the question. The square root of 18 is equal to the square root of 3 times 3 times 2. I'm going to put it in order of the pairs that we know. So 3 times 3 is 9, and the square root of 9 is 3, so I can put a 3 down below. Now what's still underneath the square root? Well, a 2. Circle your answer. Type into the calculator. I show it in the notes. Root 18 equals 4.24 or 5. 3 root 2 equals 4.24 or 5. They're so close that it's perfect. It's because the calculator answers are rounded, whichever. Check marking our answer. Okay, square root of, the calculator buttons, second square root, 18, whichever, make sure it works. So second square root 4, better get 2. Second square root 9, better get whichever. Find the yellow shift second button on your calculator. Find the square root, usually below squared, whatever. Okay, so root 54. Square root of 54. Well, let's take 54 off to the whichever, and this gets to the point where we could do 9 and 6, or we could do 18 and whatever, 3, but let's do 9 and 6. Using the biggest, closest numbers together will get you the flattest tree. 9 is 3 times 3. 6 is 3 times 2. So 54 is the square root of 3 times 3 times 3 times 2. Now, we know 3 times 3 is 9, and the square root of 9 is 3. So we can put equals 3 below. Now, what's still underneath the square root? Excuse me, square root. Square root. Well, 3 times 2, so we say 6. Circle your answer, check your answer on the calculator, type in the question, square root 54 equals 7.35, check, and then 3 square root 6 also equals that, check mark. So, off to, like, down below, I did the square root of 72, and it just like, oh, we've got 2 different numbers that come out. Well, we just multiply them, obviously. Off to the right, we want to remember the square root of negative number, square root, forgot the little 2, we can't do is no solution, empty set. Kind of looks like theta, but put a line through it. Now, the thing is, the cube root of negative 27, what's that? That's a cube root. We can do square roots and cube roots and fourth roots and fifth roots and whatever, but, well, whichever. But the cube root, well, above, there's no 2 identical numbers that multiply together to make negative 9. But we know that it's the cube root of negative 3 times negative 3 times negative 3. Do a prime factorization tree on 27 if you like, 3 times 3 times 3, with 3 negatives, or just 1 negative. Either way, we've found 3 identical numbers to get. So the answer is negative 3. Type it in your calculator. You may have a shift cube root button, or you may have to get through there through some complicated list of buttons, like mode, math, or cube, whichever. Okay, so we just saw cube root. And we can take a cube root. We can take a cube root. We can actually take any odd root. So if this little number is an odd number, we can do it. And above, if it's even, we can't even root a negative. We can odd root a negative, we can odd root a negative, we can't even root a negative. Okay, so we skipped root 72. I'm going to shrink up my stuff a tad. So again, we skipped the square root of 72 in the notes. ... Just if you have 2 things, bring them both out and multiply them. Check your answer. Okay, let's do cube root. Cube root of 24. Well, what is this? Oh, we just saw the cube root a second ago when we were talking about negatives. And we know that we need 3 things. So let's do a prime factorization on 24. 6 and 4, 3 and 2, 2 and 2, equals the cube root of, put the stuff in orders and pairs first, cube, etc. The ones that you have common first. Now this time, we have 2 times 2 times 2. So we're doing the cube root of 2 times 2 times 2. I like to do my work off to the right. Well, 2 times 2 is 2 times 2 times 2 is 8, so it's the cube root of 8. Which is 2. Okay, so back to the left. Let's circle 3 2's because this is the 3. And 2 times 2 times 2 is 8. And the cube root of 8 is 2. So if we have 3 identical things underneath a cube root, now 1 comes out. And we're left with the cube root of 3. Circle your answer. Check your answer. Cube root 24 equals 2.88. 2 cube root 3 equals 2.88. Check mark. So there's another example down below, and how you do it if you want to use the perfect cubes method. like we did above with the perfect squares method. But again, I don't like to teach it because when we get to do more difficult questions, we forget that we can use prime factorization and we get overwhelmed trying to figure out numbers that are perfect squares and perfect cubes. Okay, so that's entire to mixed radicals. Now we're going to reverse it. So it's entire if everything is underneath the root because it's all entirely underneath the root. Or it's mixed if there's mixed, like a number in front and a number underneath the root. Mixed.